there are 58 employees in a certain firm. We know that 40 of these employees are male, 14 of these males are secretaries, and 23 secretaries are employed by the firm. What is the probability that an employee chosen at random is a secretary, given that the person is a female? Okay. This is a tricky question. This is a given question. So what we're saying here is we're given that the person is a female. So let's map out what we've got going on here. There's 58 employees. 40 are male, 14. So of the 58, 40 are male, which means 18 are female, aren't they? Because that totals 58. And it said 14 of these, so 14 of the 40 males. So for the males, 14 of them are secretaries. So that means what? Subtract, 40 minus 14, that would leave 26 are not secretaries. Oops. Are not secretaries of the males. And then down here for the females, get rid of that part right there. Is this making sense how I'm reasoning through this? We've got 40 males, and 14 of these males are secretaries. So 14 secretaries, so 26 are not of those 40 males. And it says, notice this next fact, 23 secretaries are employed by the firm. There's 23 secretaries total. So 14, if you take away 23, what is that, 9 more to go? So 14 of the secretaries are those males, 9 more to go. That would mean 9 of the females have to be secretaries. Do you see how I figured that out? They said right here, 23 secretaries are employed by the firm, 23 total secretaries. We already know 14 secretaries are male, so I subtracted 23 minus 14, got 9. So 9 of the secretaries must be female. There's 18 total females, so that means 9 of the females are not secretaries. So they gave us just enough information to map out what's going on at this firm. Okay, so now let's look at their next question. What is the probability that an employee chosen at random is a secretary, given, now that given matters, given that the person is a female? So if you grab a female, so they're really saying the probability that if you get somebody at random, what's the probability they're going to be a secretary given they are a female? So you know how probability works, right? It's going to be, the probability is always the number that you want, in this case secretaries, the number of secretaries given over the total number. But you have to be a little careful here. It's the number of secretaries. We're given that they're female, so we're only talking about this group of females. We're not even talking about the males at all. Does that make sense? Right? Given, it says, what's the probability that they're a secretary given, we know, given that the person is a female. So we know they're a female. We picked somebody out of the females region, so we're saying the total is not the total of all people, it's the total of females. Do you see, the given changes the denominator because that's what you're limited to, right? If I said, hey, what's the probability that I chose a Fresno State student at random? What's the probability that it's a female? And if I just said that right there, you go, I don't know, about half the school is males and half is females. I guess probably about half. And I said, given that they're a liberal studies major. Well, I think the majority of liberal studies majors are females, right? There's more females than males. So that would change it, wouldn't it? If I say I chose a Fresno State student at random, what's the chance they're female? Given, I'm going to give you the information, hey, they are a liberal studies major. I picked a liberal studies major. Oh, well, then the chance they're female is way higher, right? You see, given changes the denominator, it changes the pool that you're picking out of. So they're really asking us, what's the probability that this person we grabbed around him is a secretary, given that they are a female? So we did get a female. So what's the denominator? We're talking about these 18 people. Those 18, out of those 18 females, what's the chance that the woman we got as a secretary? Well, 9 of them are secretaries. So it's 9 out of 18. Reduce that fraction. Divide top and bottom by 9. We always reduce fractions when we can. 1/2 is the answer.